Hey guys, in this video the brilliant Mr. B is going to be taking you through how to construct things. So using loci, using perpendicular bisects and constructing areas. Now this is a really tricky thing. There's a whole range of skills in here and we're going to work you through 15 examples at a nice slow pace. If you're finding these easy, you can skip to the hard questions at the end or speed up the video. If you're finding them a little bit tricky, then that's okay. Nobody's watching you, nobody's judging you. You can go through this at your own pace. Then you can rewind, you can pause, you can try a question and then watch the answer to see if you got it right. And then if you want to do even more examples, then there are loads of those waiting for you over on my website.
We're going to have a look at constructions and to start off a few definitions. So we have a diagram drawn for the first question. And what does each point represent? So point number one is the end of a line segment. And a line segment is the end of, it's just the one highlighted in blue here. And the next thing to look at is point number three. Now, point number three, that is an intersection. It's the intersection of the line that's highlighted in blue and the other curved line. And it's got another intersection up at the top as well. So it's got two different intersections. Now, point number two, this is in the middle of line CD. And it's in the middle, then we can call it the midpoint. So to answer the question, which number represents the midpoint? It's number 2. But it is just worth knowing that 3 is an intersection of the two curved lines, and 1 is the end of the blue curved line segment. For question 2, we have to talk about something called a loci. Now, loci is really simple. All it means is equal distance. So how does that apply to question 2? Use loci to construct a midpoint between A and B. So what we can do with this is we can measure how long AB is. So let's say that AB is 10 centimeters. Now, I'm not going to measure it accurately because it'll be a different size depending on how big your screen is. So we have to use theoretical numbers here. So let's say AB is 10 centimeters. So what we can do is we can draw something that is 5 centimeters all the way around A and 5 centimeters all the way around B. And where they cross over will be the midpoint. So let me just draw that for you. So what I've done here is I've taken a compass, you put the metal point of the compass on A, and then what you need to do is just measure the distance between the metal point and the pencil point and make sure that the distance is 5 centimeters. That's half of 10 because we want to find the midpoint. And then you draw the circle, again, with the metal part of the compass on A and the pencil drawing the green circle. Then we do the same thing with B. You make sure your compass is set to 5 centimeters. You're going to want the midpoint, half of 10 is 5. Put the metal point of the compass on B and then draw a circle. So the green circle is where your pen would be going around. Now the midpoint is going to be the intersection of the two circles. And the intersection of the two circles would be here, and we can label the midpoint C, like we're asked. So that's one way of finding the midpoint of a line using loci. Question 3 is the same thing. So we are going to measure how long AB is. So let's say this time AB is 6 centimeters. What that means is the circles that you draw, you're going to set your compass to 3 centimeters. So the metal point and the pencil point of the compass should be 3 centimeters apart. So let's draw those circles. So if you do this correctly, what will happen is if you set your compass to 3 centimeters, put the metal part of the compass on A and you draw a circle, you'll have a circle that has a radius of 3 centimeters. And I would check the setting after you've drawn A before you draw B and just make sure it's still at 3. Because what can happen sometimes is when you draw the circle, the setting can get a little bit wider or shorter. So just check it's still at 3 and draw a second circle around B. And the place where the two circles intersect is going to be the midpoint, which again, we're being asked to label it as C. You may also see it labelled as M, but just follow what the question says. Now, moving on to question 4, we've been asked to construct a perpendicular bisector. So it seems like quite a complicated word. What does that mean? Well, first, it's going to be helpful to actually draw the line AB. So let's get that drawn. And what perpendicular means is that it's going to cross that line at a right angle. So do a little sketch. Perpendicular means if you've got a line like AB, this is just a sketch, it's not going to be too accurate. The perpendicular bisector is going to cross over that. It's going to cross it at a right angle if it's perpendicular. So that's the first part of this. It's perpendicular because it crosses the line at a right angle. Now the second part of this, the bisector, so you got bi, which means two, and the sector, it sounds like bisect, like cut in half, and that's what you're doing. And what it means is a perpendicular line goes through the midpoint. So they're the two things we're trying to achieve. Now it's actually very similar to using loci to find a midpoint. So let's say we measure AB. Now again, I'm not going to measure it accurately because yours will be a different size and it won't work. But let's just say, for argument's sake, that AB is going to be 12 centimeters. That means the circle we're going to draw for a perpendicular bisector, it won't be halfway in 6. It's going to be a little bit bigger than 6. So let me draw the circles and show you what I mean. So these two circles, they're both loci, they're both equal distance from point A and point B. Now, what's the distance this time? It's not been exactly halfway, which was 6. I've done more than 6. So let's say I've done 7. So to label this, I'm just going to say it's greater than 6. And the other one would also be greater than 6, but they've both got to be the same size. So the circle A and the circle B, they're both the same size. So how do we find the perpendicular bisector from this? Because you can see they're not going to cross over at the midpoint. But the circles do have two intersections. You have an upper intersection and we have a lower intersection, and all you need to do is find those two intersections and then join them together, and that line is your perpendicular bisector. And you should find that that line crosses our main line AB at a right angle, and it's going through the midpoint. And you might want to check those two things. Maybe use a ruler and make sure that AM is the same size as MB, and also make sure that the angle is a right angle. And if those two things are true, then you have a perpendicular bisector. The key difference between this and question 2 is if you've got a midpoint, then your circle has to have a radius that's exactly half. Your compass is set to exactly half. Whereas for a perpendicular bisector, it's got to be more than half. Now, it doesn't actually matter how big it is. It's just going to be more than halfway, and it's going to work. So, for example, 7, 8, 9, they'll all get you the same answer. It's just a matter of how long the perpendicular bisector is. But we've not been asked to make it a certain length, so that's fine. Now, moving on to question 5, we have to construct an isosceles triangle. So this is going to be, again, another similar method to question 2 and question 4. So with question 2, we set our compass to exactly halfway for a midpoint. For question 4, we set it to more than halfway for a perpendicular bisector. Now, for question 5, let's say that the line AB is equal to 15 centimeters. So we're not going to set it halfway for a midpoint, 7.5. We're not going to set it more than halfway for a perpendicular bisector, let's say 10, 11, 12, any of those will do. For this, we're going to set it to exactly 15 centimeters. For an isosceles triangle construction, we're going to set it to the entire length of AB. So put the metal part of your compass on A, put the pencil part of your compass on B, and then draw 2 circles, one around A and one around B. And now you can see my 2 circles. Now these ones are huge, and you'll notice this is quite bad. One of the circles is overlapping question 3 and 4. It doesn't look great. So it's good to show this because what you'll tend to find is when people do these questions, they don't draw the full circle. They only draw the part of the circle that they need. So, for example, with circle A, we only need the bits that intersect. So I'm just going to highlight in blue the key part of the circle A that we need. And then the key part of circle B would be on the other circle, part of that circle that also crosses over. So you would just do that little part and you wouldn't draw the rest of the circle. So what I can do now is delete those 2 giant circles. So thankfully, now that I've done that, we can see the rest of the working out, especially the question 3 and 4 isn't affected by the working out for this question. Now, when you're not confident, feel free to draw the entire circle. Especially a GCSE exam paper, there should be enough space to do that. But when you're getting more confident, let's get to know which bits you do and don't need. And for an isosceles triangle, as soon as they have crossed over and you find the point of intersection, what you can do is find that point and then you can join them up with a line. So join your point of intersection to A and then join your point of intersection to B. Now, if you make it exactly the same length like I have, not only is this an isosceles triangle, it's also an equilateral triangle because all three sides are the same length. So if you set your compass to the same length, then you'll get an equilateral. If you want an isosceles triangle, then what you need to do is perhaps have it a little bit bigger. So not have it exactly on 15. Now, if your compass is less than the full length, or it's more than the full length, you're going to get an isosceles. Now, one other thing you need to take into account is if it's less than halfway of A and B, it's not going to make a triangle. So it's going to be at least more than halfway. But if it's just less, you'll get a shorter isosceles triangle. And if it's more than AB, you'll get a taller isosceles triangle. But if it's exactly the same length, it's going to be equilateral. Equilateral, all three sides the same. Isosceles, only two sides are the same. For the medium questions, the first thing we'll look at is loci of other sorts of shapes. Now, let's look at the point first, which we did with the easy questions. So it says, lose a loci to construct a region that is 2 centimeters away from point A in all directions. So you get your compass, you set it to 2 centimeters, and then with the metal part of the compass on A, you're going to draw a 2 centimeter circle all the way around A. Now, again, I'm not going to measure this accurately because you have a different screen size. The measurements will be different for you, but you can check it afterwards. From the center to the edge, you should be able to measure 2 centimeters. When it says construct a region, what that means is that everything that's 2 centimeters away from the point is everything that's exactly on that circle. So our region is everything that's dead on the line of that circle. Sometimes you have to shade inside and sometimes you'll be asked to shade outside of it. But in this case, it's just exactly on the circle. Question 2, we're going to find the loci of a line. Now, to find a loci of a line, it's the same thing. Set your compass to the number it says. So this is 1.3 centimeters. And you're going to start off with drawing circles. And you're going to draw them at both ends of the line. And once you've drawn those circles, again, just double check, it's a center to the edge going to give you 1.3 centimeters. Now, if it's not true, then you need to rub it out and do it again. Now, we haven't finished because what we've done here is find a loci of the points at either end of the line. We haven't found an equal distance from the line itself. What we also need is we need 1.3 centimeters from the actual straight part of the line in the middle as well. Now, how do we do this? Well, just find the very top of the circles and the very bottom of the circles and join those up with a straight line. And then once we've done that, we can identify the loci. So it's the point that's 1.3 away from every single part of that line. So it's going to be the outside part portions of the circles, which I'm just highlighting in green here. So the thick line is going to be the loci. But I'm not going to carry on around the circle. I'm going to continue doing the straight lines I've just drawn. And the loci then joins onto the next circle and goes around that. And then again, rather than continuing around that circle, it then goes down the straight line we drew at the top. So it's a bit rough now that I've highlighted it, but with you it should be nice and clear. And what you don't want to do is you'll notice I've got the green lines on the inside that show the kind of rest of the circles. You do not want to rub those out because that is part of the proof that you've done this properly, you've not guessed. You're showing construction lines, you're showing how you've done it. So the loci, which is 1.3 centimeters away from any part of that line, is a bold green line around the outside. It's not the thinner green lines that's just part of your working out. You don't need to highlight your lines, by the way. You could just leave them as they are, be clear what the loci is. For question 3, we're going to find the loci of a shape, a polygon. And it's going to work the same way. You're going to set your compass to what it says. This says 54 millimeters. And you'll start off drawing a circle at every single corner of your shape. So put the metal part of your compass on each corner one at a time. Draw the 54 millimeter circle around. Check the radiuses at 54 millimeters. And then in between each circle you draw, just double check on your ruler that it's still at 54. Because what can happen again is that you can get kind of set maybe to 55, 56 or 53 with the pressure that you put on it as you draw the circle. So always check in between each drawing. So now what we found is the loci of the corners of our shape. Now we need to find the loci of each line. It's the same as the previous question. So find the tops of your circles for the top line. And once you've identified those tops, then you can draw your line in between them. For the bottom part, then you want the bottom of the circles at the bottom and connect those up with a straight line. Making sure that straight line should be parallel to the lines in your shape. For the leftmost part, the leftmost circles, and join those up with a straight line. And for the right, the same thing. For the rightmost points of the rightmost circles, and join those up with a straight line. Then all I'm going to do, just so you can see where the loci is, just highlight it. So starting at the top, you can nice bold lines you can see. So put the straight line, curving around the circle, back down into a straight line. So it's just the outside, curving back around, another straight line, another curved segment, and then another straight line, and another curve. And you're going to leave on the page the kind of all the inside lines. That's part of your working out. And if you think it's not clear, maybe just go them lightly with a rubber. We need to make sure that they are visible because you do get marks for them. At any point you see anything that's maybe not 100% parallel, then you need to rub it out and have another go. Maybe your compass changed setting from one circle to the other, and that's why it's not parallel anymore. And the next thing we do is find a perpendicular bisector of an angle. Now, to bisect an angle, what we need to do is just find the actual corner of the angle. And then what I'm going to do is just find how long AB is. So let's say AB is 4 centimeters. Now, it doesn't really matter how big our circle is here. We want enough working out space. So ideally, I want something just under halfway. So let's say we're going to draw a 1.5 centimeter circle. So I've set my compass to 1.5. I've drawn the circle, and there it is. Now, what do I do next? Well, the next step now is look at the intersection of that circle and our two lines. The intersection on the line AB and the intersection on the line BC. And what I'm going to do now is draw the same size circle around those 2 points. Now, actually, it doesn't matter if it changes a little bit, but again, we just want some good working out space. So we want it to be, less than halfway through AB. So enough space for both circles to be. So I'll just say I'll do another 1.5 centimeter circle. Now you can see with those two circles so close together, it looks a little bit messy. But what we're looking for is we are looking for the intersections of the two circles, and we can see the intersect here. Now to make our line bisector, what we are going to do is we're going to join that point on to the corner, the kind of center vertex of the angle. Now I'm going to draw a straight line. And that straight line that I've drawn in purple is the answer. That is the perpendicular bisector. So I'm going to highlight it a little bit so you can see that is the perpendicular bisector. Now, what does that actually mean? Well, what this line is it's halfway through the angle. So if I just highlight the angle itself, these are the two lines that make up the angle. And that's drawn the curved bit of an angle that you usually have. You can see the purple line should be going through the center of that angle. So let's say it was a 40-degree angle. That line cuts it into two 20-degree segments. Moving on to question 5, what the perpendicular bisector of the angle EFG. But you can see we have a triangle drawn, and triangles have got 3 angles. So which one do we need to cut into? Now, what you're looking for here is the middle letter. The middle letter is where the angle is. So we're looking at the angle at F. So we're going to cut this angle in half. It's going to follow the same method. So get an idea of how big FE is roughly. Try and draw a circle that goes less than halfway along it. So you've got plenty of working out space, but the size isn't a major issue. And now, like we discussed back on the easy questions, you don't actually need the full circle. And what you can do is just draw the part that you'll need. And what I'm looking for are the intersections with the triangle. So what I'm highlighting in green here is the only part of the circle that you actually need. So let's get rid of the rest. And now at those 2 points of intersection with a green line from the circle and the angle, we're now going to draw circles around those 2 points. And again, the size doesn't matter as long as both points have the same sized circle. My suggestion would be, a little bit less than halfway along F and E, so there's plenty of space. Now, again, with these two circles, you don't need to draw the entire circle. And what you'll commonly see is just a part where the intersection is going to be drawn. So this is the part of the top circle typically seen drawn, and then here's the part of the bottom circle. You don't need the rest of it, so let's get rid of it. And now we've found that point of intersection between those two circles, we're going to join that up with the kind of center of the angle. I'm going to do that with a straight line. And that line, that is the answer. And it should be cutting the angle exactly in half. So again, just highlighting the angle to show that here's where the angle is, and the purple line should be going halfway through. And what you could do in the exam, even get your compass out, get your protractor out, and actually measure it, and just make sure the two halves are the same size. And last thing I'm doing, I'm just going to highlight that bisector, just so you can see that that is the answer. Again, all the other construction lines need to be left on there because they're proving that you did this properly. Moving on to the hard questions, we now have different things, more complicated problems that you can use with loci. A lot of it's kind of recognizing which kind of skill you need to use. So for example, question 1, we have a rectangle. We have to shade the part of the rectangle that's closer to B than A. Well, how can we find that out? Well, if it's closer to B, it's going to be closer to B from the midpoint. So we need to find the midpoint first. So we can do that with a perpendicular bisector. So I'm going to draw a circle around A and B, and I'm going to set my compass to more than halfway the distance between A and B. And remember, you don't need to draw the full circles. Only do that if you're not very confident. You only need the part of the circles where you think the intersection is going to take place. So the bits I'm highlighting in green now on the B circle, and the bits I'm highlighting in green now on the A circle. So just these two crosses. Then you find the places where those lines intersect, and with a ruler, you draw a straight line between those 2 points. You should see that it joins onto your line at a right angle, and it should also be at the midpoint. So you can measure the angle to make sure it's 90 degrees. You can measure distance between A and the midpoint and B and the midpoint to make sure it's exactly in the middle. And if it is, then we'll be asked to shade the section that's closer to B than A. So the answer is going to be the blue section that I am now shading in. For question 2, the shapes are drawn for you already. I want to shade a region that's at least 5 centimeters away from Z. That's going to be more, it's going to be outside of Z. So what I'm going to do first is I'm just going to do a bit of working out here, and I'm going to be shading outside of Z. So I'm just going to do a little shading line all the way outside of Z, just so I know where I'm looking at. Then it says we have to be within 5 centimeters of X. So it'll be inside the X circle. So I'm just shading inside the X circle. Now, what I'm looking for here is the place where it's green and it's pink, and that's going to be our final answer. And it looks like it's going to be this part here inside the X circle, but it's not going to be in the Y section because we didn't have any green shading there. So the blue part now is my answer. And then what I suggest you do at the end is just get rid of any other shading so your answer is not ambiguous. It's really clear that the blue part is the answer. Now, question 3 is the same kind of question as question 2, but the circles haven't been drawn for me. The first thing you need to do is draw a 2.5 circle around A. Again, setting your compass, the metal part on 0, the pencil part on 2.5, and then put the metal part on A and drawing a circle, and then do a 3 centimeter circle around B. Now, I'm saying centimeter there because on the scale, typically something like this, where the scale is equal to 3 kilometer. Perhaps that's 1 centimeter, and that's what you would be setting it to. If that line isn't 1 centimeter, then you have to scale up or scale it down based on whatever measurement you have. But again, usually it's going to tell you that something like 1 centimeter, or in this case it's 3 kilometers, it's going to be 3 centimeters is equal to 3 kilometers. But you have to work that bit out yourself. So you should have something that looks like that, and then do some practice shading. So it's got to be 2.5 away from A. So it's got to be outside the A circle. So just do some practice shading there. I'll rub this out later. And then it's going to be 3 kilometers away from B. So it's going to be outside the B circle as well. So what we're looking for now is an area that's been shaded in both colours. And it looks like, you can see an area here where it's both, and there's an area here where it's both. So it's going to be everything on the outside of both circles. So all I'm going to do now is go shade in on the outside of both circles. I'm going over the lines, that's fine, and we'll be rubbing out the inside soon. Using this to be in a box, so just shade in all the way to the ends of the box. And then any kind of work on the inside, we can start to get rid of that. Make it really clear that it's the outside section that's shaded in. And there's our answer. Moving on to question 4. Now we've got another scale here, and we have 2 things to do. We have a 1 kilometer and a 2 kilometer line to draw. Another way to approach scales is you've got a 1 kilometer line, that's going to be a quarter of the way across, and a 2 kilometer line is going to be halfway across. So you can actually use a line and either find fractions on the line to find, for example, 2 kilometers is halfway, or if it was say 8 kilometers, then you can make the line twice as long. So just be looking at that line really carefully to make sure that your compass is set to the right measurements. So first one, a 1 kilometer line from AB, and then a 2 kilometer away from CD. So I'm going to do the 1 kilometer lines, let's highlight it in a colour to show you. 1 kilometer AB. So I'm going to do a 1 kilometer circle around A and around B. And then for the 2 kilometers away from CD, I want a 2 kilometer line around C and around D. And once we've done that, then it needs to be a loci from A, B. So we need to look at the lower parts of A and B and join those up the line. And we don't need the full loci of A, B. We only need the lower section of it because we're not actually drawing a full loci. We're just kind of comparing measurements inside of the rectangle. Then with the same thing with C and D, find the upper parts of those circles, and we're going to join those up. So let's read through the question and see what it wants shaded in. So it wants an area that is 1 kilometre away from line AB. That's outside of AB, away from AB. We want the area that's 2 kilometres away from CD. That's outside of CD, beyond CD. So it's going to be the inside section there that's shaded in both colours that I'm going to colour in. This is the shaded section that I'm looking for. And again, leave the rest of the working out there. That's proving you've done this accurately using the right methods. Moving on to question 5. So we have a scale that lies for 8 kilometres and we are drawing 8 kilometres. So we want to be 8 kilometres away from WX, so do an 8 kilometre circle around W and around X. But then also Z is also going to be an 8 kilometre line, but it doesn't have 2 letters. It's only got 1 letter for Z. So we're only going to do it around Z. So let's draw those circles. So now we've drawn those circles. WX is 8 kilometres away from double X. That's going to be a loci. So we need to find the lower parts of W and X. Again, we don't need the top parts because that's not inside the rectangle. And I'll connect that up with a straight line, which should be parallel to WX. And then looking at Z, there's nothing else to do with Z because there's no line involved. So that's going to be talking about that circle particularly. So what we want is to shade in, we want 8 kilometres away from ZX. So let's say it's going to be more than 8 kilometres away, we'd shade that part in. And then if it's going to be more than 8 kilometres away from Z, then we would shade that part in. We want to colour in the area that's shaded in both ways. And we see the outside isn't shaded in green, but the bit on the inside is going to be shaded in. So the area we want shaded in is the area I'm now shading in pink. It's outside of Z, and it's also outside of the line WX. And I found that by using loci.